Okay, good morning, grade sixes, or it might be actually afternoon, but welcome to another lesson that I'm just going to go through on the laptop. Okay, for you guys, it'll obviously be on the screen. So, what we're going to go through today is theoretical probability. To recap what we did yesterday, we were looking at section D, and we were looking at how to write out a sample. Okay, so we're looking at, for example, if we had a coin and we flip the coin once, just once, not twice, not three times, but just once, the chances are we could either get heads or tails. So just listing out all the different possible outcomes we could have. Okay. However, when it comes to mathematical or theoretical probability, we are more interested in the likelihood of something happening, how probable something will be. So way early on in the chapter, a couple of weeks ago, we were using words to describe this. So, for example, if you were to ask someone if there was loads of clouds, you would say it's highly probable that it would rain. Or we were asking questions along the lines of, if someone is aged 13, what are the chances are that they would live to 14? Highly probable. We were using words. Now we're going to dive into theoretical probability, which relies on maths to come up with a probability. Okay? And the whole concept about this is that it's, as we've always been saying, theoretical. It doesn't mean it will definitely happen in real life. But according to maths and according to theory, these are the chances of an event occurring. Okay. We are going to be representing this as a fraction. Okay. Sometimes you can represent it as a percentage. So let's look at coin tossing again. It seems to be a common example here. When a coin is tossed, there are two possible outcomes. We've gone over this, heads or tails, and you guys know how to write that in the correct mathematical form now. From the symmetry of the coin, we expect each of these results to occur 50% of the time, or one time in every two. We say that the probability of getting a head with one toss is 1 over 2. And write probability of head, so the P stands for probability, H for heads is equal to 1 over 2, or 1/2. So we read this as the probability of a head occurring is 1/2. Likewise, the probability of getting a tail is 1/2. And we write this as P equal to 1 over 2. What you should realize here is that these are the only two possible outcomes, heads and tails, as we discussed earlier. Okay? And that if you add this half of the tails to this half of the heads, so a half plus a half, it equals 1. When we are doing theoretical probability, if you add all the probabilities together, it should always equal 1. Keep that in mind. Okay, there's an investigation over here. We're not going to do that. I think that you guys have done enough investigations already and you can see what's going on here. Instead, we're going to jump straight into the exercise. I will give a brief explanation of what that means though. Okay, so basically what is happening in this investigation is that they are tossing two coins at the same time. So in other words, two coins over here, flick both of them at the same time, and then we're going to look at what we can get. And I want you to think about that. What are all the possible outcomes that could happen if you flicked two coins at the same time? The answer is in front of you right now in your textbook. One possible outcome could be that you get two heads. Okay, each coin that you've tossed up now land, and both of them are heads. Or you could toss up both the coins. One of them is a head. Okay, in this case, the orange one is it an orange or brown one, while the other one is a tail or tails. Another outcome is that the orange one is tails and the silver one is heads. And then obviously the last outcome would be no heads and only tails. So in other words, there are four possible outcomes. We can read it over here. We practiced this in the last lesson. Okay, heads, 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 tails, tails, heads, or tails and tails. I do want to clarify one bit because I think this might be confusing to some of you. Is this middle part over here? Okay. So yet again, the first letter represents the first coin. The second letter represents the second coin. So even though in this instance over here, with the middle two, it's kind of the same. One head, one tails. One head, one tails. The difference is which coin is a head and which coin is a tails. In this first instance over here, it is the bronze coin that is a head, and it is the silver coin that is a tail. However, in this instance over here, which is represented there, okay, it is the bronze head that is actually a tail, and then the silver one that is a heads. Okay, you should know how to do that at this point. That's relatively straightforward. But now we need to write this as probability, as a fraction. Okay? You should realize that there are 4 possible outcomes. If there are 4 possible outcomes, that means that we will write our fractions as a number out of 4, as a quarter. Okay? So if we look through all of these instances again, we should realize that there's one time when there were 2 heads. Okay? Meaning 1 out of the 4 times there were 2 heads. 1 over 4. It is therefore a quarter of the time. So the probability, write that as P, of having, the probability represented by the letter P, that there are 2 heads is 1 over 4. Okay? Likewise, out of all the times we threw coins, or tossed coins, there was also one time where there were no heads. So we write that as probability no heads, 1 over 4. Okay? Then we look back to over here and we can see that 2 of the times, okay, 2 of the times there was 1 heads and 1 tails. So in other words, we're going to say 2 of the 4 times there was 1 head and 1 tails. And we know that we can simplify 2 over 4 as a fraction to 1 over 2. We should know that by now from what we did earlier in the year. So this is how we would be writing theoretical probability. Okay? You go through all the possible outcomes and you list the chances of them occurring. So the probability of no heads is 1 over 4. The probability of 1 head, it happened twice, so 2 over 4, which is therefore a half. And then the probability of 2 heads would be 1 over 4 as well. Okay. When you do questions like this, it is quite advisable that you write out the sample size as well over there, like was done there. Okay. Once you have your sample size, it's relatively easy then to write out the probability. And actually the first step that I want you to do is you need to write down the total amount of outcomes possible. And that's actually why I want you to do the sample size. So that will always be the denominator in your fraction. So in this instance, it was 4. So we can see that our denominator is 4. Okay, sample size 4, denominator 4. If we have a sample size of 6, the fraction denominator will then be 6. You can see that when rolling a die. Okay, so let's have a look here. When a die is rolled, there are 6 possible equally likely outcomes. 1, 2, 3, 4, 5, and 6 that form our sample space. So we've done that before. That is how you would represent the sample space for a die. The probability of each outcome occurring is therefore 1 over 6. There's a 1 over 6 chance of landing on a 1. There's a 1 out of 6 chance that it lands on a 2. There's a 1 out of 6 chance that it lands on a 3. And then the same for 4, 5, and 6. Okay. So therefore, if I'm asking you what the probability, remember P stands for probability, of getting a 5 is, it would be 1 over 6. I hope that's not confusing some of you, okay? The 5 is just one of the possible outcomes, okay? 5 is just one of the possible outcomes. So if it's one of the possible outcomes, it goes on the top as the numerator. How many outcomes are there in total? 6, so that's on the bottom. Okay. For some events, though, there may be more than one outcome. And this is when you just need to read your question slightly more carefully. So the probability of a 5 or a 6 occurring. So we're basically asking, what are the chances of the die landing on either a 5 or a 6? Okay. So in other words, if we go back to our sample size over here, we can see it can either land on a 5 or a 6. That is 2 out of a possible 6 events occurring. So we represent that as 2 out of the sample size 6. 2 over 6. Okay? And you should realize that you can simplify that to 1 over 3, but you get the point. Here's another example. What is the probability of the result being even? Okay? Even number. So we go look back at our sample size. Okay? There's a 2, that's an even number, so we've got 1. Okay? There's a 4, that's an even number. Now that means there's 2 possibilities, and 6 is an even number, 3 possibilities. So yet again, 3 possibilities out of a sample of 6. So 3 over 6. So 3 of the 6 outcomes are in the event. Okay, and yet again, we can write that as 1/2 or 1 over 2. So here's the golden equation that you need to learn. I would recommend writing this down every time you have one of the questions. The probability of event equals the number of outcomes in that event. So just to be sure about event, this is what we mean with the probability. The event here is even numbers. So number of outcomes that in that event, we calculate it as 3. And you divide that by the total number of possible outcomes. So yet again, back to the die, there's 3 even numbers that could possibly happen out of a 6 potential outcomes, so 3 over 6. Here's an example to go through. I'm going to go through just one, and you can go through the second one by yourself. Okay. 2 blue and 3 white discs are placed in a bag, and 1 disc is randomly selected from it. 1 disc. Okay. So we have 2 blue and 3 whites. So the first thing I want you to realize here is what is the sample size. Okay. So yet again, what that means is how many different outcomes are possible. Okay. You're only picking once. So therefore, that means you could pick 5. Okay. There's 5 different outcomes that could happen. So our sample size is 5 because there are 5 discs. That means automatically our denominator for the probability will be 5. We know that. Okay. Question reads, what is the probability of a blue disk? We have 2 blue disks possible, so then is 2 over 5. Probability of a blue is equal to 2 over 5. If you can understand that, the next question is pretty straightforward. A white disk, what is the probability of that? We already know that our sample size is 5, so that's on the bottom, and we know there are 3 white disks, so we write that as 3 over 5. Please, 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 make sure that you are doing this in the correct format. I want you to write the answers that you will do for the exercise like this. P, bracket, whatever the probability is of what you're working for. In this case, it's a white disk, equals, and then the fraction. I don't want you to just write probability equals 60% or 3 over 5. I want you to write P, and then in brackets, what you're looking for equals 3 over 5. Please write it in the correct format. I can't emphasize that enough. Okay, getting back to what I mentioned a little bit earlier, you should realize that these are the only possible outcomes that you could get, okay? And therefore, if you add this to that, 2 over 5 to 3 over 5, if you plus those two together, you should get 5 over 5, which equals 1. Think about it if you're not too sure. What is 5 divided by 5? 1. To clarify that more, if we had 5 slices of pizza and we had 5 people, so in other words, we had to divide 5 slices of people amongst, 5 slices of pizza, not people, amongst 5 people, each person would get 1 slice. Okay. If you do all the probabilities, it should always equal 1, and that's a nice way for you to check your answers and check your work. If you're landing up with a fraction that is not a full whole number, okay, if it doesn't equal 1, then you've made a mistake somewhere. Okay, thank you. So you can practice example 6 by yourself. I highly recommend what you do is you don't look at the answer over there. Don't. Okay, I know you're all looking at it now, but try not to. Do the actual question, A and B, and then check if you've got the answer correct. Okay, what you will do in class today, this is Tuesday, you will do exercise 19E. Please do as much as you can today. It's quite a long exercise. However, it will not be for homework, okay? Exercise 19E will not be for homework. You will complete exercise 19E on Thursday, okay, on Thursday. If it is not complete by the end of Thursday, then yes, it will become homework. Okay, thank you very much, grade 6s, and I will see you in a week's time. Thank you.